Hi, I'm Kevin O'Connor, and welcome back to Ask This Old House, where we'll go anywhere to answer your home improvement questions. Today, I'm going to work with an electrician who's going to show us how to keep your electrical panel and your whole house safe.
And I'm heading to Utah to show a homeowner how to use the sun to make hot water.
And look what was carrying this old deck, this rotted old post.
So we're going to replace them with some new posts that are going to last a long time.
Salt Lake City is a place of celestial beauty. It's why the pioneers of the Mormon Church founded their church here over 150 years ago, when their leader looked around and proclaimed, "This is the place." On the shores of the Great Salt Lake at sundown, the clouds, the mountains, and the water all merge into one. And when the snowflakes start falling, people head to the slopes to ski and snowboard. We're at the base of the Wasatch Mountain Range. You can actually see Mount Olympus right over there. And this is the house we're going to be working in today. And today we're going to be talking about hot water, how to make hot water using the sun, solar thermal. We're going to install a couple of these panels up on the roof. They're designed to look like skylights. And with these two panels, we're going to get about 65 to 70% of the domestic hot water for this house. Now, our contractors are already inside underway. Let me show you how the homeowners make hot water now. Chuck Travis is our homeowner. Now, Chuck, you live here, just you and your wife now. But you have two water heaters. What, one for each of you?
Well, today, but with the kids in the house, and it's a 5-bedroom house, we used a lot of water in the past.
All right, so that uses a fair amount of gas. So there's two gas-fired water heaters. We're going to have to remove these, and we're going to replace them with one tank that's got a gas backup, but it's collected to solar panels up on the roof. Now, helping us with the installation is Bob Dudley and his crew. So, Bob, what are you going to do to get started here?
Well, what we've already done is we've already run our supply and return lines from the attic space down in here to the mechanical room.
Oh, so it looks like there's stainless steel. That's great, and they're already insulated. And so it's one piece, no fittings inside that chase.
That's correct, no fittings.
All right, so what else you got to do?
Well, next thing for us is to remove the two existing tanks and get started that way.
Let's do it.
Okay.
With the gas shut off, now we want to drain the water heaters. With the water heaters drained, we can now cut the pipes and remove them. Now, water heaters can be heavy and often difficult to get out of the basement. You have to give it a big bear hug. Well, Bob's got a good tip. Put a couple of temporary pieces of black pipe onto the top of it, and that'll give you a handle to get it out of here.
Me a handle? Give us a handle.
Let's go. Tip it to me. A little bit. There we go. These handles are great.
Yeah, they're a back saver.
I'm going to actually export this back east. So the guys are getting ready to put those solar panels up on the roof right now.
Now, Richard, this is one of the two solar collectors that we'll be putting up on the roof.
All right, so Chuck, you can see right here that there's a connection right here that's going to have antifreeze going through it. It's called propylene glycol, just a fancy name for antifreeze.
Well, that's good, because it's going to freeze here in the wintertime.
That's right. It's going to help in the freeze in the winter, but also in the summer, this liquid gets so hot that if it was just plain water, it could turn to steam. Now, if you look at this, this is a cutaway of an inside of a solar collector. There's a header right here. That's a pipe, a copper pipe. That's where the antifreeze is going to pass through. You can see right here, there's a copper sheet with a special coating on the top. Below it is insulation. When the sun hits that collector sheet, it's going to heat up that liquid. If I turn it this way, you can see there are small tubes right here. They're going to pass through the collector. Now, the way the antifreeze passes inside the collector is this. It comes in, it comes up through those small tubes, it comes up to a header right here, and now it passes down through the other half, and it goes into the second collector up on the roof.
Oh, great.
All right, we ready to go?
Okay, we're ready to go, but first, with this style of collector, we have to remove some of the roof shingles. So now I think it's up to the roof.
All right, good.
We start by peeling back the shingles.
So I see tar paper under there. You're going to leave that in there?
We are, Richard. We have to go right down to the tar paper. That's where we'll mount the collector, and luckily the tar paper looks good.
Good. Good. All right, looks like we're getting ready to put the collectors up here pretty soon. All right, here's our second panel. Drop it. I'm going to drop it. Got it? Yeah, there you go. Good.
Okay, now what we're going to do is we're going to cut 3 holes in the roof. First hole is here for the supply of the glycol from the basement to the collector.
Yeah.
Our second hole here connects the first collector to the second collector.
Yep. Comes from that other next one, yep.
Right. Third hole is going to be here. We're going to take the return of the glycol back down to the
Great,
basement.
and the loop is complete. All right.
Correct.
All right, boys, it's time to drop these panels. Now, the screws are only holding them up temporarily. Let's pull them out. and drop it right down onto that 2x. All right, here we go, boys. How's it look?
Looks good.
Good. All right. All right, here it comes to you. Great. Now we screw the collector flange into the rafters. Any solar system needs to know when the sun is actually out. So for that, we have a temperature sensor that'll mount right here. Once that temperature sensor is in there, if the sun hits this collector, it heats up the glycol and it tells the pump to come on down in the basement. A little bit of this grease will actually increase transfer to make the sensor work better for us. Now we're ready for our first connection, the supply up from the basement. This is actually a stainless steel corrugated pipe with insulation on the outside, and it's a solderless connection. You don't need to solder it at all. You can see there's a compression nut right there, and we just tighten it up, and it makes for a perfect high pressure connection. To make the connections panel to panel, they make a short piece of the corrugated pipe with union connections. And those connections are just the same as the supply pipe. All right, so the return line's connected, right?
That's
so
right.
now, with that done, we've got all of our mechanical connections done and our thermostat sensor. We can actually head to the basement, right?
We can. I'm going to leave a couple guys up here to make sure that we're all watertight.
Good.
We can go down and check it. So while we've been up on the roof, my guys have been busy here in the mechanical room.
Boy, they sure have. Look, it looks great. They have been
Wow,
busy.
what a change.
All right, well, let me take you through your solar system. You remember these flexible lines that connect up to the panels up on the roof? That's going to go up to the collectors and then back. The hardest part of many of these jobs is to find a way to fish these through the building. So Bob's crew found a place right here next to this flue pipe up through the building. So that's great. Now, they worked their way right down to this. This is called a pumping station. You can see a circulator pump right here. You can see a control right here, a couple of temperature gauges. Out of the bottom, there's two more flexible lines, and that comes out of that pumping station and works its way right over to here to this water heater. So the glycol, or the antifreeze, will actually come into this coil. Now, inside this tank is a big coil that's filled with that glycol, and it's going to heat up the water. The tank itself is filled with water ready to go for the faucets. So imagine a sunny day. Collectors feel that temperature, bring the pump on. It might go up and get so much temperature might come back, and this water tank might get to be 170, 180, 200, too much to come out of the faucets. So what I like seeing is this. This is a safety device called a tempering valve. The hot water from the tank will mix with cold water right here to give a mixed temperature out to the faucet that is consistent. I like seeing that temperature gauge too. Now I got to tell you, the sun doesn't always shine. At night or on cloudy days, and so for that, there's a gas backup right here. They've already run their gas piping to connect that. They still have a little bit of venting work to do for both the furnace and the water heater, but after that, you can have a solar system with a gas backup and plenty of hot water.
That sounds great. You guys have done a terrific job. I'm really impressed with the sophistication of this
I
system.
take none of the credit. Bob and the guys from Harris Dudley did a great job. Thank you.
Thank you, Bob.
We'll see
Thank
you.
you,
It was a lot of
Richard.
fun. I'm out of here. I'm going to catch a plane.
All right.
See you.
See you.
Great. See you guys.
So it actually seemed like a pretty big system with a lot of work up on the roof. You had to pull off the shingles, cut into the roof, and then eventually re-shingle back to those panels.
Those collectors are designed to look like skylights, and so for that there was a fair amount of installation. I've never used this system before. The ones I've always used had a racking system that mounted it onto the roof so you had fewer penetrations, but it looks beautiful when it's done.
Right. And so what did the whole system cost?
Well, that labor and material would have been about $10,000, but there are incentives involved. State, federal, and utility tax credits and rebates gets it down below $3,000.
Wow, less than $3,000.
Absolutely.
Sounds like a bargain.
It is.
We all depend on our electricity, but it can be dangerous. Circuits can overload, they can trip, and they can arc, which can cause a spark and can cause a fire. But there are ways to protect ourselves, and master electrician Scott Caron is here to tell us about some of those. Hi, Scott.
Hi, Kevin. How are you?
I'm well, thank you. You brought us a working service panel. This is great. You've actually lit it up for us right here.
Yes.
And inside, I guess, is the first line of defense, circuit breakers, which we're all familiar in seeing.
That's
But
correct.
what exactly are these protecting against?
Circuit breakers protect you from an overload or a short circuit. Those are the two things.
So an overload is I plug too many devices into an outlet. I've got the hairdryer, the space heater, and the
Yes.
toaster going. It pulls too much energy across that
That's
wire.
correct.
That heats up, and maybe you get a fire.
Heats up, it can create a fire on the wire. So it protects the overload capability in that instance. And then, of course, cutting a wire by accident is the short circuit version.
And it'll just simply trip off, and you'll notice it when you go down to the box, and you can turn it back on and reset that
It can
circuit.
go all the way off, or sometimes it'll go in the middle, actually.
Right, okay. Now, there is also in here, you brought us an arc fault circuit interrupter.
That's correct.
What is that protecting against?
It protects us against the same items that the short circuit and the overload that a standard or conventional circuit breaker protects you. However, it goes to the next level of protection and protects you from real small sparks or real small arcs. A typical situation may be where you have a plug that's extending an outlet in a room going across to the other side of the room to give you a dresser outlet, and you would use this. Well, to hide it, you would put it underneath the carpet.
Right.
And in this situation, it shows you that it got worn out from walking on the carpet, and it creates a sparking situation or a faulting situation.
And so this is where it literally jumps from one wire to the other, or there's a small connection creating that arc, which is really a spark.
That's correct. And then another instance of a possible sparking or arcing is where you might have a plug that's slammed against the wall, and it creates an effect which might create an arc.
I am guilty of that for sure.
Yes.
So this circuit breaker senses the spark, whereas this one does not?
They both sense spark. The standard or conventional circuit breaker has a much less sophisticated circuitry than the arc fault circuit interrupter does. This one has an electronic circuitry which is monitoring the circuit all the time, and as soon as it senses that arc or flash, it shuts off.
All right. Now we've also got ground fault circuit interrupters, and we see them, I think, almost all the time in wet areas like kitchens and bathrooms. I recognize this one because it's got two buttons on the front. You can literally test it and reset it right there. What are these protecting us against?
The GFCI outlet is protecting against ground faults. Any ground fault is where electricity travels the path of ground. And an instance where I can show you that is the right side of the receptacle is your power, or your hot wire as they call it. And if you go to the neutral, you can see the illumination of the voltage tester is showing you that there's power in this receptacle.
So it's coming out and then going back through the neutral, back into the outlet there like it's supposed to.
Exactly. Now when I take the power, which is right there, and I touch it to a known grounded source, which could be water that is touching something metal, it shuts off.
So in this case, the electricity was coming out, but it wasn't going back through neutral. It was going to that ground wire.
That's correct.
That's the problem.
Yes. And so what they've designed is the device for life safety with any sort of ground fault, whether someone's got wet feet and they touch something that's live, or in a bathroom or a kitchen instance where everything's wet.
So it's only if you touch ground, correct? If you touch something else that wasn't grounded.
So we have power here, and if I touch the wood bench, which is not grounded, it will not trip.
Terrific. All right. Now, in this case, ground fault protection is built into this outlet, but you can actually get GFCI protection other ways, and in fact, you brought us an extension cord.
That's correct, Kevin. This is a cord adapter that allows you to get GFCI protection where you don't have it in a device or a receptacle that's non-protected. You would plug it in. And the receptacle now is protected through these three plugs, and you can plug your Christmas lights or skill saw in, and it has the same LED indicator on it that the device has.
So if I'm using that circular saw outside, but I plug the cord into a non-protected indoor outlet, it gives me the protection I need.
Yes, and then if you don't have any of these two, the option of going into the electrical panel is also there, where you have a receptacle protection at this point.
So this is a GFCI circuit breaker right here?
That's correct. And this is protecting this outlet right here on the same with the same effect as a receptacle does.
And I notice it also has a test button, so by pushing that it trips, and then I can just simply reset it. Same deal with the arc fault circuit interrupter?
Yes, that's correct.
And what of these devices is code?
They're all code, Kevin. They have different applications. The arc fault circuit protection is required in all homes that are built now, and the GFCI protection is required in bathrooms, basements, outside, and kitchens, wherever there's water.
Arc fault for all buildings built now, so this is for new construction.
New construction or renovating if you need to protect the circuit for arc fault.
Okay,
yes.
so we may still have some of these older circuit breakers in the box, and this is a good time to update them to either arc fault or GFCI.
Absolutely. Yeah.
All right, well, some good, safe information, Scott. Thank you very much.
My pleasure. Thank you.
Wood in direct contact with concrete is never a good idea. This is the likely spot for water to accumulate, and then the end grain of the wood will suck up the water, and that's where you're likely to get rot. Now, having pressure-treated wood will help, but ideally, you've got a separation between the wood and the concrete. And if you don't have either, if you don't have pressure-treated wood and you don't have separation, well, that's a recipe for trouble, Tom.
It sure is. Now here we have a fir 4x4 post that's sitting right on top of the concrete, which is actually sucking up water, and you can actually see a hole in it where it's starting to rot. Let's see how bad it is. Oh yeah, that's pretty gone.
Oh man, all right. So we replaced the posts.
We're going to replace these 3 posts right here on the outside.
How do you want to get started?
First thing I want to do is temporarily shore the deck up. We took a measurement from the underside of the beam down to these blocks on the ground, and we cut our post a little bit longer. As we hit the temporary post in place, the deck posts go up. All right, that's it. The weight's off, and now we can remove our old posts. First thing I want to do is remove these diagonals. Now we got to pull the nails in these brackets right here so we can free up the posts. All the nails out?
Yep.
All right, let's see what the post looks like on the bottom.
Oh my.
Oh yeah, I would say that's definitely rotted. Yeah, look at that. All right, let's get the other ones out. All right, now we got to remove these small hangers right here that are supporting this 2x4 that our ladder's attached to. There's a nail in there somewhere. All right, Kevin, let me show you what I have here with the old post. We have a hole on the bottom of the old post. This pin that sticks out of the concrete pier was meant to keep the post on the pier, so if someone should hit it, it won't slide off.
But it doesn't stop the post from rising up.
Uplift, no uplift protection. So what we need to do is improve upon that, and we're going to use this post base right here. We're going to set it on top of the pier, and we're going to fasten it.
All right, so this is going to give us a separation between the concrete and the bottom of the post, so that's going to be nice to slow down the rot.
Right, and it's also going to make the connection so the post can't lift up.
So we've got to get this into the pier. How are we going to do that?
I'm going to drill a hole into the post because I can't use this threaded rod because these threads are no good. I can't use it. Now I want to place the post base over the pin, and right about in the same location the post was. So I can right about there. And so now I can drill a new hole right beside this pin for a new fastener. Using a masonry bit and a hammer drill, I'm going to drill down about 2.5 to 3 inches. All right, that's it. Now I want to cut that pin off. Here's how we're going to attach our post base to our concrete pier using this mechanical fastener right here. It actually goes into the hole, and at the bottom of the fastener there's actually a cone. At the top there's a nut. When I tighten the nut, the cone pulls into the cylinder, expanding the sidewalls, locking it into position. All right, set the post base into position, and I'll take the fastener and drive it into the hole. All right, now I got to tighten that nut. That's it. Now remember, the corner post here and the center post over there were rotted, and the deck was down about 1/4 of an inch. What we did is we pushed the deck up 1/4 of an inch to get the post out, and we actually pushed it right back into its original position. So now to get the post height, we want to measure off of our post base to the underside of our beam, and our new post will be 51 3/4 of an inch. Now to nail it off, I'm going to use these nails right here. They're specifically designed for metal hangers, post caps, and post bases. Now I'm going to reattach this 2x4 nailer to the post using a small timber hanger. Our 2 outside posts are in, and before we install our center post, we want to make sure that this beam is straight. To do that, we've measured down from the top of the beam 16 inches and placed the nail. Now we'll take a string line and we'll run it across the porch, connect it onto your nail, pull it tight.
We've got a nail here that's also down 16 inches.
And I'll measure down from the top of the beam to our string line, and we have 16 inches. So now we can cut this post. Okay, knock out the temporary posts. Now the old diagonal braces that were nailed to the deck before were actually nailed to the beam here and to the post here, and they were placed on the flat. I like to take the diagonal braces and place them flat against the beam and flat against the post, which gives me more surface to screw to, and it's a stronger connection.
Okay.
All right, those diagonal braces are really important when you're building a deck up on posts like this because it really stiffens it up laterally.
All right, so some good bracing, some new posts, and we've got some new bases too. We're good to go.
We're good to go. These are going to outlast you and me. Well, me anyway.
All right, well, if you've got questions about your house, we'd love to hear from you. So keep your letters and your emails coming. Until next time, I'm Kevin O'Connor.
I'm Richard Trethewey.
I'm Tom Silva.
And I'm Roger Cook.
For Ask This Old House. Hey, so how long would you last if you were pressure treated?
A long time.
Yeah.
I think I'm already pressure treated.
That's right.